Okay, so here we are, lesson 2.5. We're going to be starting with guided notes question 63, but we've got to get there first. So here is a warm-up. Okay, for the warm-up, sample A and sample B come into contact with each other. The yellow arrow shows the direction of energy flow. The graph shows the temperature for sample A over time. Okay. What does the graph tell you about the temperature of sample A over time? What can you infer about what this graph for sample B would look like based on the graph for sample A? And this should be guided notes question 63, not 26. Okay, I'll actually fix that right now while we're watching. This is 63. Okay. So what can you infer about what the graph for sample B would look like based on the graph for sample A? Okay. So looking at that a little closer, go ahead and answer in your guided notes question 63. Okay, what does the graph tell you about the temperature of sample A over time? What can you infer about what the graph for sample B would look like based on the graph for sample A? Okay. Nope, wrong one. There we go. Okay, we know that the temperature was not changing at the beginning. We know that the temperature was changing at the beginning, but not at the end, if you notice that, okay? This must mean that the energy was transferring in the beginning, but not at the end. Today, we'll investigate why the transfer of energy stops and what it means about the molecules of the two objects. Okay, so today we'll investigate this question. This is guide notes question 64. Why does the transfer of energy between two things stop? Okay, so get that written down, typed in. All right, we learned that energy transfers when collisions happen between the molecules of two things. You'll use the sim to gather evidence for the new investigation question. Okay, so just going back and looking at your notes, what we have for 65, you're filling in those blanks. Okay, so going back there. Okay, so energy transfers when collisions happen between the molecules of two things. Okay, you'll push two samples together in the sim and examine how their temperatures and energies change after they come into contact. Then you'll record your observations. The link to the sim is in your notes, and you need to answer the questions on Amplify, okay? Which means, and your link is also in your notes for that. Okay, so here's the sim link and the activity link. You're going to follow the instructions for the sim and complete the tables and follow up questions in the activity in Amplify. Okay, we don't do that very often, but we're doing it today. Okay, then what did you observe in the sim? Okay, so you should have paused the video and gone through the sim. So then we're going to talk about what did you observe in the sim. Okay, here's a key concept review. Okay, this was key concept number 6. Energy is not created or destroyed. Therefore, as energy transfers, it increases in one part of the system as it decreases in another part of the system. Okay? So, guided notes question 67. You can see energy conservation in your data. This is called law of conservation of energy. Energy isn't created or destroyed. It transfers to another part of the system or is converted into another type of energy. Okay, get that down in guided notes question 67. The law of conservation of energy is that energy isn't created or destroyed. It transfers to another part of the system or is converted into another type of energy. Okay. We can see this by calculating the total energy of the system before and after the energy transfer. We've been using the sim to track energy transfer as energy flows through samples in a system. Energy can take different forms, such as thermal energy and energy of motion. We will continue to investigate how these different forms of energy are related. Okay, so here's a vocabulary term for you. Guided notes question 68, the word change, when something becomes different over time. Get that down. Okay, then we have guided notes question 69, the word stability, when something stays mostly the same over time. That is stability. Put that down. Okay, we've got a few more before we end. Okay, guided notes question 70. How can you use the words stability and change to describe the systems you observed in the sim? So take a second to think about that. Write it down. How can you use the words stability and change to describe the systems you observed in the sim? And then finally, a big vocabulary word that we have and we'll be talking a lot about is equilibrium. Equilibrium is a balanced state in which a system is stable, such as when two or more samples are at the same temperature. Okay, get that down, and we will stop there today.